Hello and thank you everyone for joining us. My name is Alex Janicki and I'm the Director of Marketing for TriStar. I'm here with PTC Technical Specialist Cody Wiltrout. In a moment, he'll be covering the PTC Creo Product Insight Extension, a powerful tool to collect and share data for the CAD environment. Please leave any questions and we'll have a brief Q&A session. You'll also notice a white paper is available for download. You should be able to access that on your screen on the interface. And that kind of just goes into more specifics. I'm now going to pass it over to Cody, and he'll have a presentation for you and a demonstration. And Cody, can you hear me?
Yep. All right. I'll go ahead and take over. So nice to meet you, everyone. My name is Cody Wiltrout. I'm with PTC's Virtual Center of Excellence, about 45 minutes outside of Pittsburgh. And today I'll be taking you all through Creo Product Insight. As Alex said, we'll start with a brief introductory PowerPoint. And then once we're done with that, we can jump into the demonstration in Creo. So I'll go ahead and start here by sharing my screen. Can you confirm that you can see my screen?
Yep, just popped up.
All right, perfect. So to start off with a little bit of background on why PTC really developed this extension to help, support some of the challenges that both our customers and other people just in the market are facing. When you design products, they're based on assumptions. That's just the way it is. And what you really want is to know if those are good assumptions, because the better your assumptions are, the better that, whatever it is that you're designing will perform in the field. And so we do tests, you attach sensors, you make prototypes, you measure, record, collect back data that you want to use in your next iteration or to improve whatever design it is that you're working on. And obviously this is your real world data, but what's the best way to take that information and actually be able to utilize it to make better designs so that you don't just have a data lake of information that's sitting there and not being used. So to address these challenges, PTC offers Creo Product Insight, which allows you to bridge that gap between, the real world information that you're collecting and being able to utilize that in Creo and being able to really improve your designs. So some capabilities that help to back it up as a solution. First off, it is an add-on extension to Creo, and it works directly with it, and it will provide you some specialized tools to help design for connectivity and being able to bring in some of that IoT information. It uses sensors to help capture any relevant data streams that you have and return that real-world data from the physical products. So you can actually bring in sensors onto your models and help feed in that data and utilize that through your design, so that you can replace assumptions with actual real-world facts on how things are really operating out in the field. This then allows you to optimize or improve and respond to any data that you're getting, to get that feedback, see how that affects your designs, and see what the best way to move forward from there is. So you can easily define and place physical measures or sensors into your Creo assemblies. So those sensors we talked a little bit about earlier would allow you to feed in some of that IoT data. And there's also a new instrumented assembly so that you don't have to worry if you bring one of those sensors in that you're gonna, mess with your existing base design that you want to keep. Along with that, you can seamlessly connect to sensor data from a file. So if you don't have an IoT platform necessarily, but you do have some sensor data that you want to use, that's fine. You can bring in things like CSV files and such to feed that data in anyway. But if you do have, for example here, ThingWorx, you can connect into ThingWorx and have that sensor data come directly down from ThingWorx into Creo so that you can utilize it. So that kind of gives a brief introduction into the topic. I'll go ahead and bring up Creo now, and we can see how that works in practice. So for today's demonstration, we're going to be working with this throttle body here, and we've got this cylindrical opening with our disc on the inside, and we've designed the disc so that it fits basically perfectly there inside of the opening. But that doesn't necessarily mean that it will work perfectly like that in the real world when we have loads and things on it. So for example, looking at this, we could come to the back and we could say, okay, I want to place a structural or a thermal load here on the back. And once we do set those loads, whatever they are, we could, run some simulation based on those loads that we set and find out, maybe it does work, maybe it doesn't quite fit exactly what we are looking for. But we're going to have to kind of decide what those loads are going to be based on our assumptions. Instead, we could choose to bring in some real sensor data and use those for the loads to try to get, realistic values back and really see what's happening out in the field. So to do that, we're going to start by bringing in one of those sensors that we can then utilize down the line in bringing in that information. So to start off, we're just going to bring in sensor A. And in our case here, sensor A is pretty simple. It's almost just a disk cap here that we want to use. But if we come into the model properties, we can see that we can give it an angle parameter. So that parameter then is set to the actual angle that we're going to use in that disk. So that gets that extra added parameter there for this sensor that we're going to be using. So once we have the sensor all set up and ready to go, we can just insert it using insert sensor into the assembly, and then you can constrain it however you want. Once we have that set up and constrained, we can see there that we have that angle associated to the sensor, and it's currently undefined in terms of the model. So we want to set what that's equivalent to in the model. In our case, the angle that the disk is setting at. Once we set that relationship up, any changes that we make to the angle for the sensor will automatically make changes to the model as well then. So if we take this sensor angle here and we change it from 50 degrees to say maybe 45 degrees, we can run that and see that it's automatically going to adjust the angle that our disk is sitting at there. So now that we have this in here, obviously our goal is to try to make sure that this disk can open and close easily. So we are going to go ahead and set some features here to check if there's any displacement, so that then we can later down the line use these displacements to see if there's an issue for the clearance there for the disk that we want. So now that we have all of that set up, the next thing we're going to do is go ahead and bring in another sensor, and this sensor is going to be for the load on the back here, for the thermal load that we're going to be applying. And in our case here, this is a pretty simple, structure for our sensor. It's just basically a cube almost, and that's fine that it's a cube. It can be as simple or as, advanced as you want it to be. If you want it to look like a real sensor that you have on the object, that's fine. You can model it out and put it in like that. If you just want a really simple, cube just to get the job done, that's fine as well. It doesn't necessarily matter. Now that we have the sensor in here, we've set its parameter equal to the temp load. So then we can bring in data and feed it to that temp load and have it run through that sensor. So you can see here we have that temp load set as well. So now that we have this temperature load set, we have both of our sensors for the angle, and we have, a feature set up to measure some of the clearance down there between the disk and the walls. We can go ahead and start with some data. So there are different options here in how we want to get the data in. If we wanted to just bring in a CSV file, for example, we could bring that CSV file in, choose to either run all of it, or if we wanted to run a few data points from here, we could choose to just run a few of the data points. Kind of up to you. Alternatively, we can come into ThingWorx and we can utilize ThingWorx to bring that data in for us. So ThingWorx is PTC's rapid application development platform that allows you to connect into multiple systems or objects and aggregate that data into a mashup. So essentially, it's allowing you to connect out to those edge devices, whether it be sensors on, a prototype or to an actual, object out in the field that's running, and get that data back and aggregate it into one place and make it easy for you to view. And we're going to push that data that it's going to be getting down into Creo so that we can use that in our design. So the first thing we're going to want to do from the Creo end is we are going to want to publish out these sensors that we've put into this assembly so that ThingWorx can see them and send the data down to them. Once we have those published out, we can come back into ThingWorx, and if we reload, we can come into our models and see that we do have that model that we just published out. So we want to make an event so that we can have the data come from here in ThingWorx down to this, model that we've created. And we're going to set it so that anytime there's a data change, it activates the event and can send that information down. So anytime we get new information in, we can send that down to Creo. So now we need to map the data. So obviously in our case here, we have our thermal sensor and our angle sensor. So we want to map the temperature over to our temperature sensor and our angle that we're getting read in to our angle sensor. So it's pretty simple to use there, easy mapping, and not any coding or anything necessary to do there. Now that we have that set up, we're just going to connect into our ThingWorx server, and then we can start bringing some of that information down. So in our case, we have it all set up. So we'll just say send to Creo and send that information down for us to use. We'll get a notification alerting us when that sensor data is ready to be used, and then we can load in the data. And so we can see we're getting in some sensor or some temperature and angle data from ThingWorx that we can now use with our throttle body here. And if we run all, we can actually see the disk rotate through those angles for the different angles that are associated to that sensor. Now that we've got this information, we want to really utilize it and make some improvements to our design. So maybe we could come into simulate and we could say, okay, well, we have this thermal load that we have this information for. So let's go ahead and maybe run a simulation with this thermal load and get some feedback on what's actually happening. So we'll set the value to temp load that we're getting from our temperature sensor, and then we can go ahead and run any simulations that we want with that. So we'll open up our analysis and study here and start getting ready for what we're going to run for our analysis. Once we have everything set up, it'll go ahead and run through, and then we can display our results. So again, for anyone who's not familiar with Simulate, you have a lot of different options for being able to view that information, review your results. In our case here, looking at some of the feedback, we can see whether we want to see the spectrum in thermal or structural, whatever is the most useful for you to really be able to digest that information and make improvements to your products. So now that we've kind of gone through setting up, a simulation, see how that looks, look at the loads, maybe we want to go ahead and look more specifically at that clearance that we set up earlier. So we have some of these, already set information inside of here. So we're going to go ahead and start just adding in a few more features here to finish this off and really be able to get the full utility out of the information that we're bringing in. So we have our vertical displacement for both the top and the bottom to be able to see if there's any issues there, see what those actually are. But we're going to need to be able to tell if even with those displacements, there's actually an issue. So we're going to go ahead and set up another analysis relationship here to decide whether or not there's actually a problem and give us back, a pretty simple answer so that we don't have to worry about really thinking through it. So we can go ahead and run through it once here just to see what that looks like with those, displacements at the top and the bottom. And we can see we do have some displacement, but as I just said, that's kind of a lot of work then for you to decide whether or not that's an issue. Obviously, there's going to be displacement. We maybe want a more simple answer. So we're going to come in and set up that relationship that I talked about and say, okay, well, whenever it's meeting, a certain threshold, that's obviously too high, then we're going to have a problem. So we'll set up this relationship to give us a simple interference, yes, no, back is an answer. So now that we have these different features that can give us back our information, we're actually going to set in another sensor and we're going to have these features be the parameters for that sensor. So now we have these answers that we're getting back, and we can display them all very easily through this sensor in a table. So the first thing that we're going to have to do is define these parameters for the sensor. So we just come in, choose feature, find the feature that we're looking for, and set those relationships. So we can come back for each of these. We still have 3 undefined. Just choose the undefined part, come in, choose feature, find the feature that we're looking for, and then once you have it, go ahead and select that out. In our case, we're going to start adding in the displacements for the top and the bottom, and then it'll create that connection for us. So, it's kind of a little bit of upfront work to get all of the connections set up and everything in line, but it's going to save you work in the long run from not having to run each of these through individually, not having to look at that relationship each time, just being able to have it all set up in a nice table for you to be able to quickly go through and say, okay, at these temp loads, we can see that we do have an issue, there is an interference, so we're gonna have to make a change, or no, we ran through all of the sensor data that we're getting back and there's no issues. So now that we've set up those relationships, we can see on our sensor here that information back, and that's for the first run that we did. So we can see for that entry state that we have all of that information. But again, we could now choose if we want to maybe run through all of this different information that we got in from ThingWorx, or in our case this time, maybe we'll just choose 1 or 2 points and say, okay, let's run that. And we can quickly see, okay, for the first one, yeah, there's no sensor issue. We're not gonna have a problem. But for the second one, yeah, at this load, there is gonna be interference. It's not gonna be able to open or to close all the way. And obviously that's not something that you want. So from there, you could take this new information that you've got, take this insight from your in the field data and use that to make some improvements, maybe reduce down the size of your disk a little bit, look at the loads that you're getting, figure out what the best way to approach that problem would be, and from there make improvements to your design so that you don't have any problems. That kind of covers at a high level a demonstration there on how Insight can really bring in data, make it easy for Creo to use, and give you back those results so that you can use that information to improve your designs. I'll go ahead and close off here with a few more slides. So some value that this can really bring to a team is that it does allow you to validate your design requirements with real world data. So you might think that it's probably going to be used in the field like this might be what it looks like, but now you can really bring that information in and streamline that process. This also means that you can ensure new product designs provide the necessary data streams that you're going to need to test and validate that it works. Along with that, it improves the quality of both current and next generation products by being able to identify and correct some of those flaws that you might be able to see, or even if there's not a flaw, be able to get information back on possibly even how users are using something and see how you could improve the design around that for the next generation. And that leads into being able to identify those business opportunities for new products or features that you could have with your designs. So that covers my overview today on Product Insight. Thank you all for your time. Alex, I don't know if there were any questions that came through during the demonstration.
Nope, it looks like there's no questions that I can see. That was excellent information. Thank you, Cody.
Yeah, absolutely.
Thank you all for joining us. If you want to learn more, a link with further information as well as a recording of this webinar will be sent via email containing a link to our website. Further information on this Product Insight extension for Creo can be found at .com. Also, feel free to contact us at any time. A replay will be available on demand on our resource center at TriStar shortly. If you would like to rewatch this, just visit tristar.com and have a great rest of your Tuesday and an excellent week. Thank you, everybody.
All right, thanks again, everyone.